Hi everyone, my name is Brandy Bell and welcome to another presentation hosted by the Data Alliance Collaborative. This one is part 2 of our Netezza technical deep dive. And today we have Russ Shaw joining us, who's a resident senior solution architect for Premier. He has experience in industry for over 13 years. We have a lot to cover, so we're going to go ahead and get started.
Thank you. Thank you, Brandy. Brandy is right. We do have a lot to cover, and last time we had to cut short because we went into a lot of things last time and did not realize that there were a lot more things left. So we are today going to start somewhere in between. We are going to start where we had almost left off last time. So we were discussing, or we were completing the discussion on distribution and co-location last time, and we had just started talking about zone maps. So I'm going to just do a repeat of the distribution and co-location concepts in Netezza, just because I think they're probably, for a database developer, they're probably the most important concepts to remember in Netezza. So I want to put some emphasis on it. And then we have also a Netezza 3, third deep dive that we are hosting in September, which will give you a lot more idea on query explanations and optimization on how to understand a query and its performance, and also will give you some direction on how to manage users and groups, which is much more generic and applicable to all other databases. So before we start distribution and co-location, let's remember some of the core concepts we discussed about Netezza architecture, right? We started by talking about barriers to performance and efficiency in traditional data warehousing. These barriers emerge from the fact that traditional data warehousing has relied on symmetrical multiprocessing architecture. That's the hardware architecture of traditional data warehousing systems, and that relies on big CPUs, lots of big CPUs, big RAMs, but shared storage and shared input-output fiber bandwidth, right? So we talked about this phrase that we use in Netezza all the time, the shared everything architecture in infrastructure. So the shared everything infrastructure is a big problem because this is the infrastructure that is used for all the other things, not just for data warehousing. It's also used for your Exchange servers, for your web servers, for your application servers. It's the same type of infrastructure that's used for it. The second thing we talked about was the loosely coupled architecture for the infrastructure, right? So, and the software. So you have the hardware and software that are loosely coupled. Then within the hardware components that you have, your storage, your server, your hardware itself is loosely coupled. It's not tightly integrated. So with Netezza's answer to solve these problems, is to really tightly integrate all of this in, let's say, a model that has been used in the industry by something like Apple, right? Everything is tightly integrated, the software and the hardware itself is also tightly integrated. So Netezza uses this kind of an Apple model to kind of resolve the traditional barriers, to remove the traditional roadblocks that you find in data warehousing, and to give you optimum performance. It has both hardware and software components that we looked at. We looked at the SPU and the SPA. We looked at the host that Netezza uses with hundreds of different SPUs in the Netezza box. Think of the SPU as you think of a computer. You know, it has a CPU, it has a RAM, it has a fiber optic input-output bandwidth network, and it has data disks or hard disks, if you will. And then what it has additionally in a SPU is an FPGA component. FPGA component is used in Netezza hardware to basically create an assembly line of data streams, right? So when Netezza is scanning data from the hard disks and relaying it back to the CPU, in between the FPGA core is actually doing a lot of work that the CPU does not. So traditional data warehousing system, the CPU does all the work. It does the select clause of your query, it does the from clause of your query, it does the where clause of your query. Well, not the same thing in Netezza. The CPU does not do all of those clauses. The select clause and the where clause both are actually performed in Netezza by the FPGA core. And there are software components to it that we looked at. I'm not going to deep dive into those software components because we've already covered that last time, and hopefully some of you were there so you have an idea of what those components were. What we're going to start with today is the distribution and co-location concept, which again we covered in detail last time, but I want to re-emphasize this because this will give you a much better idea of how Netezza distributes data, stores data in the spoos in the box, right? So table distribution in Netezza is nothing but a way of storing data across data slices or hard disks. Data slice is another term for hard disk, right? And this distribution is determined by a distribution key, and distribution key is nothing but a column in any table, right? There are two traditional methods of distribution in Netezza. There is the hash distribution and the random round-robin distribution, right? Every table will have a distribution method implemented on it, irrespective of the fact that you have defined your table, your DDL, with a distribution key or not. If your DDL for a table does not include a distribution key, Netezza will automatically distribute data based on the round-robin method. Distribution is probably one of the two most important factors in determining performance in Netezza. The second being, it is associated with distribution, so distribution is the most significant. The second one that I was going to refer to is redistribution. So if you have not distributed your data correctly, Netezza will try to do distribution again. And the second is the skewness that comes with the way you distribute data. So really it is distribution that results into all these different problems that you see in Netezza's performance. And we'll talk about that in a moment. Now, co-location is the other side of the distribution coin, right? You distribute data in a certain way so that you enable co-location in Netezza. And what does this co-location mean, right? Co-location is distribution of two or more tables on the same spool in Netezza based on the same value. Once again, I want to repeat that the spool is nothing but a node, a computer which has a hard disk, a CPU, a RAM, and an FPGA core. So I want to refresh everyone's memory on what does this spool mean, because we are using jargon of Netezza to kind of give you an idea of how Netezza stores and processes data. Right, so co-location is distribution of two or more tables on the same spool based on the same value, right? So Netezza does not know or care if the column is a surrogate key or not. So it's not necessary that you distribute your data on a surrogate key, although it is recommended because surrogate keys are typically high cardinality, but it is not necessary. You can distribute data on anything. And what do I mean by surrogate keys? Most of you who are in data warehousing know a surrogate key is nothing but what we call primary keys or foreign keys or dimension keys, right? That's another name, a generic name for a surrogate key. If the fact and dimension tables are distributed on the same column, then Netezza will use the hash algorithm to generate a hash value of that column value, and it will store all data on the same spool based on the hash value. So let's say you have an encounter table and you have a patient table, and you have distributed both the encounter and the patient table on the patient surrogate key. Let's say you have a patient called John Doe, right, who has a surrogate key 1234, right? We have distributed both the patient table and the encounter table on the patient surrogate key 1234 for John Doe. All the encounters of the patient John Doe will now be stored in the same spool. And that's the entire point of doing this, so that that spool does not have to access any data for that patient from anywhere else, any encounter data for that patient from any other spool. It can do all the processing in that same spool. Now, typically, when you are generating a data warehouse query or when you are running a data warehouse query to retrieve data, you don't retrieve data for one single patient. You retrieve data for hundreds of patients. You retrieve data for 1 year, for 6 months, etc., for certain kind of an encounter type, for a certain kind of medication, for a certain kind of specimen. That's the kind of queries you are typically running in your clinical data warehouse, right? And when you run that, you are trying to retrieve data for multiple patients. And so it's a good idea to have distribution on something like a patient key, a surrogate key, or an encounter surrogate key, because then if you have 100 spoos in your Netezza box, all those 100 spoos will work simultaneously to return data for the patients that are distributed on them, right? And the entire idea of distribution is to have parallel computing or distributed computing happening in parallel, so that all the spews are working away together in a symphony to generate data and return to the Netezza host that can then compile and assemble that data and return to your business intelligence software or application, or to your Agility or Toad-like softwares that you are using to retrieve data, whatever software you are trying to retrieve data. This spoos and the way you distribute data will enable you to process data simultaneously. And that will generate the powerful performance Netezza has. There are some candidates for distribution keys. There is a way to distribute data correctly or rightly or efficiently as opposed to not distributing it that way. So we recommend that you use a high cardinality column, like a surrogate key, right? We recommend that you use an integer data type column, right? We recommend that the columns you use for your distribution key will distribute that table rows evenly across all data slices, right? So if your patient table has, let's say, 500,000 patients, and you have 100 spoos in Netezza, that will enable you, if you use your patient key for your distribution strategy, that will enable you to distribute almost 50,000 patients on every single spool, or maybe it's 5,000. I may have my math incorrect there. But you have 5,000 patients or 50,000 patients on every single spool, and that spool will be responsible for working on only that portion of your data. So it's not inundated with a lot of information to store or to process in that sense. You base your column selection for your distribution key on the equality search. So you want to make sure that you use something like patient key or encounter key, because that's the kind of key that you will use in your joins in your data retrieval queries. And remember, data retrieval is the big point here, not data insertion. Data retrieval is the big point in data warehousing, because you are retrieving huge amounts of data, right? Select columns based on frequently used columns, right? Another thing to remember is, a couple of things to remember here are, you don't want to use Boolean data types or character data types. Not the most efficient way to distribute your data in Netezza, right? You also want to avoid multi-column distribution. This greatly reduces generality. So one of the things a lot of people like to do is like, let's combine patient key and encounter key and we have covered all the problems in our distribution strategy. Or they will say, this is more frequently the case, let's use our different dimension keys. You know, we have encounter type dimension, we have patient dimension, we have specimen dimension. Let's use all of these keys in our tables, in our specimen fact table. Let's use all of these three keys and we'll distribute our data efficiently. Not the case, because if you think about how you're distributing your data in clinical data warehouses, you would think about it this way. Each patient can have multiple encounters. Each encounter can have multiple specimens. And each specimen can have multiple lab results, right? So High cardinality is good, but that doesn't mean that your lab table should be distributed, your clinical results table should be distributed on clinical result surrogate key, because that is extremely high cardinality. And besides, it will not allow you to do co-located processing. If you distribute that same table on, say, patient or encounter, which is a little lower cardinality than clinical results, but still a high cardinality, you will find that all your John Doe patients, all his encounters, all his specimens that were withdrawn from him over the multiple encounters, and all the clinical results are living in the same spool. And as we know, we never really query data for one single patient. We query data for multiple patients at the same time. So it's not like we are going to create some kind of data skew or process skew in Netezza, right? We are not going to do that. We are actually going to enable faster performance by distributing data on a patient or an encounter because multiple spools will be working to get us that data. And this brings us to a point that we highlighted last time. Netezza is not very good at micro queries. If you had a query to retrieve only one patient in Netezza, right? Select star from all records for John Doe, right? Then Netezza's performance will lag. It will actually be slower in Netezza. And the reason is this. It is both data skew and process skew, right? So we're talking about data skew and process skew. And on my screen, you're also seeing the commands that are used in Netezza for how to implement a distribution key. And they're very simple. You have your create table DDL, and all you're adding to it is the distribute on clause, right? So that solves how you're trying to do your distribution keys. But we were talking about data skew and process skew. I'll quickly jump to data skew and process skew. A couple of other things that I just omitted here are CTAS, on how you implement CTAS, and the other thing is how distribution columns cannot be altered by an alter command. So those of you who are database developers need to know this. When you are changing distribution on your tables, it's a much more complicated process to change distribution on your table. That complication is resolved if you use a tool like Aginity, right? Aginity generates all these DDLs for you automatically when you are changing your distribution on a table. So I would highly recommend for those of you who are using Netezza to always use Aginity. Toad will not work as efficiently as Aginity. Embarcadero will not work as efficiently as Aginity. And the simple reason is basically distribution and how efficiently it does distribution and other commands of Netezza. There are a lot of other commands that Aginity does very quickly. I'll go back quickly now to data skew and process skew because we were talking about how retrieving only one patient in Netezza can be actually have lagging performance than retrieving hundreds of patients at a time or hundreds of encounters at a time. And the reason is Netezza is not very good at micro queries. It's because it uses this distribution strategy. It uses this idea of grid computing or parallel computing in Netezza, right? So what is data skew? We looked at data skew and process skew last time. Data skew occurs when a data is not distributed evenly across all spews, all the data slices, right? You use a Boolean data type column, right? Or you use many dimensions like encounter type, which can have maybe 50 or 100 different values. Many dimensions like race or gender. Gender is really a kind of Boolean data type, but not necessarily. You use other Boolean data types like patient class, inpatient or outpatient. You distribute data on these kind of columns and you are bound to create data skew in Netezza. What does data skew mean? You are only storing data in a few data slices or few spools in Netezza. And all the other spools of Netezza have no data. All the other disk data slices have no data in them. And this is data skew. So let's say your Netezza box has 100 spools in it, right? And let's say you used a Boolean data type to distribute data. Let's say you used sex that is male or female, what happens then? You're only using 2 spoos to store all the data. You've created data skew. And inevitably, this data skew will create process skew, because process skew is nothing but utilization of fewer spoos than are available for processing your data. You have 100 spoos available for processing your data, but if you end up using only 2 spoos, then you're not using Netezza's power for performance on your queries. You're only using 2 spoos. So data skews will most probably always result into process skews. But process skews also occur when you choose columns like date data type columns, right? When you use calendar date columns for your distribution strategy, right? You can cause a lot of process skews, because typically I am going to only retrieve data for 1 year or 2 years, let's say 2013 and 2012. But I have distributed my data on date columns. So all my spoos which have data for other years will never be used, right? So that can cause a lot of process skew. I'm using only a few spoos on which the data for these years are stored. So process skew is another problem that we have to solve, and therefore we recommend not to use Boolean date data type columns. We recommend not to use date data type columns. We recommend not to use mini dimensions like encounter type, patient class, etc., right? The other problem that is associated with distribution is broadcasting and redistribution, right? Broadcasting is not necessarily bad. Broadcasting occurs when you have mini dimension tables, when you have Boolean type dimension tables. Hopefully you're not creating dimensions out of Boolean data type columns, right? Because that's just a bad strategy. In Netezza, at least, you should create junk dimensions. I'll not go into what a junk dimension means for those of you who don't know. But suffice it to say that junk dimension is a combination of multiple mini dimensions, right? So you should use junk dimensions in Netezza. But if you have many dimensions, it's not that bad. You can have a dimension like encounter type dimension, right? It's got probably 50 or 100 values in Epic, as far as I know. And it'll be very useful to have that kind of a dimension. Netezza will choose to ignore if you have a distribution strategy on that kind of a dimension. It will say, this is too small a table. I don't care. It doesn't incur any cost. I'm just going to broadcast this table to every single spool. So if you have 100 spools, Netezza will say, the host will basically pick up that table and broadcast it to all 100 spools so that you can have co-located processing. Right? So that's broadcasting in a nutshell. Redistribution, on the other hand, occurs when it is not possible to distribute both tables on the relationship keys. In this case, Netezza will redistribute the needed columns to other disks. Classic case of redistribution for us happens when we have medication or drug dimension, and we have, what is the other one? The specimen dimension, right? Specimen dimension in Premier has probably something around 7,000 values or 8,000 values. Medication has multum. We use multum as one of our terminologies for medication, and I think it probably has 100,000, maybe more. Maybe I'm mistaken. Maybe 100,000, something like that. ICD-10 diagnosis, 140,000 values. We will never distribute data on, ICD code. We will never do that because we don't care for those kind of small dimension tables. We'll allow Netezza to redistribute those kind of tables because that ICD code is still being used in your join. It's still being used when you join it with your encounter table, right? And Netezza will redistribute the ICD dimension as necessary based on the join. And we'll allow that distribution to occur because, it's not that bad for Netezza to redistribute that data. In this case, one table is distributed by the join key and the other table is not distributed by the join key. ICD-10 is not distributed by the join key, whereas encounter SK is being used in our distribution. So that will obviously cause some redistribution. But now let's take a scenario where you have double redistribution, and this is a no-no because this will cause a lot of problems. If neither table of a join is distributed on the join key, right? If neither table of a join in your SQL statement is distributed on a join key, a double redistribute is occurring, right? This is a classic case when you distribute your data on patient key and you are querying data and retrieving data based on your encounter key, right? So this is bound to or will happen, and this will cause double redistribution of data. You will be redistributing both your encounter table and your ICD table, right? And so how do we solve this problem in Netezza? That's a question that we all have to kind of think about. Do we want to distribute data based on patient key or encounter key? To me, that's the central problem in clinical data warehouses. If you are using Netezza or Greenplum, for example, because Netezza, Greenplum, and Vertica use a similar architecture. So it's a central question for these data warehouse appliances in clinical space. And I would recommend that depending on the kind of querying you are doing, you should have the distribution strategy accordingly. So I would say you should, if you are doing physician performance kind of measures like ACO, like PQRS, I would recommend that you have patient key as your distribution key, patient surrogate key as your distribution column, right? And if you are doing patient safety kind of domain and reporting on patient safety kind of domain where it's encounter which you are interrogating through your queries, then I would recommend you use encounter key. So, and that means I'm also recommending you redundantly store your data because that will give you the most effective performance, right? So I'm saying you're storing your data twice, not once. And that's completely fine because Netezza does not have data limitations. So now this can be a problem if you have intraday micro batches. But if you have nightly builds, there is no reason why you should not be building the same databases multiple times with a different distribution strategy. Okay, we can talk a lot more about it, but I have to move on. And I have to talk about zone maps. This is where I left you. So I took the first 20 minutes just to kind of recover everybody to where we were with distribution. And now we are at zone maps. So what are zone maps? Zone maps are nothing but a map of where your data is located. That's the simplest way of explaining. Netezza stores data in data slices or hard disks, right? Each of these hard disks has pages. These data slices have a logical configuration of pages and extent. Each page has 8 extents, or I forget how many extents, and each extent is made up of 3 megabytes of disk space, right? And zone map is an internal mapping structure that stores the min and the max value of each extent. By default, therefore, a zone map is created on an integer column, on a date column, and on a timestamp column. This is by default. Netezza will automatically generate for columns with this data type a zone map. It will store the min and the max value, and it will store the frequency of the value occurrence and the dispersion of the values. It will store a whole bunch of statistics for it in the zone map, but only for integer type columns, that is small int, big int, etc. columns, and data type columns and timestamp data type. Only for this the system will generate it, right? If you want to generate it for other columns, you will have to create a cluster-based table or materialized views. So any character data type columns, numeric columns, float columns, decimal type columns, etc. You will have to create CBTs, cluster-based tables, or materialized views, and we'll come to them in a moment. When a table is dropped or truncated, the system updates the zone map, obviously. The system removes that zone map, right? The zone maps are stored in your host, in your Linux host, which is a SMP architecture host, unlike the rest of the Netezza box, which is based on AMPP architecture, which is multiple multi-processing unit. The SMP host is the symmetric multi-processing unit, and the other one is the massively parallel processing unit that you have in Netezza, the MPP unit, right? Zone maps are obviously typically used at an FPGA level, and they're used at an FPGA level for your data restriction. So you don't want to scan a lot of data. Data warehouses are notorious for table scans, and zone maps are used for basically not scanning data that is not required. And the title of my slide says zone maps where ignorance is bliss. And it's because zone maps are the anti-index strategy of Netezza. Netezza doesn't create an index. Netezza doesn't have anything called partitions or index, and that's because Netezza does not know where the precise data record lives. It only knows the min and the max value of the extent, and based on the min and the max value, Netezza will say whether it wants to query that extent in the data slice or not. It will decide the strategy of querying a data slice based on the min max value of the zone map. So it doesn't know precisely where John Doe lives in the data disk. It only knows what's the min and the max value for the patient key on the extent, and based on that it will create the query on whether to query it or not. And that's why the zone maps are really not an indexing strategy. So Netezza also automatically creates zone maps when you are doing an insert, update, or it updates your zone maps when you are doing insert, updates, and loading of the table. There is a generate statistics command also to update maps in Netezza so that it's aware of the latest min-max values that you have created. And typically we recommend you run the generate statistics command after a big build every night or every week at least. I think we typically do it once a week, but you can do it nightly too. So let's talk a little bit about CBTs. CBTs are cluster-based tables. They're nothing but they're nothing but a way of clustering records based on a key value and storing them in the nearby extents, right? So there is nothing virtual about it. CBTs will force you to store data in the nearby extents based on a column value, based on a key, and CBTs are a way to rearrange data within all extents in the same data slice, right? So, if you have data being inserted based on your admission date column, right? If you have created the table and organized it on admission date column, what it will do is basically store all that data in nearby extents based on the admission date. Now, if you're querying data based on admission date in your where clause, right? If your where clause has admission date between a particular 6-month date range, the query performance will be really fast, right? However, if you are querying your data based on your discharge date and you have organized the table on your admission date, you have a problem because your discharge dates for every admission could vary significantly. So then you have organized your admission dates and they're living in separate extents, far by extents, so you have to cobble up data at that point, and Netezza has to work a little harder. So CBTs can be useful, but they also cannot encompass all the use cases you have. In order to solve that problem, Netezza has proposed a different kind of a solution. It's called Materialized View. So we'll take a look at it. Materialized View is not what you think about, what you think of as Materialized View in Oracle or SQL Server or any other traditional RDBMS. It's very different what it means in Netezza. Now, a couple of things to remember. I've already referred to that the performance can be impacted if you choose a certain kind of organization key or a certain kind of key in clustering your records into a table. But at least there is one benefit with CBTs that you don't have with redistribution or distribution, is you can change the CBTs with an alter statement. So that's one way of one positive that it has, but I think the negatives far outweigh the positives, and so it's not recommended that you use CBDs. CBDs were useful. People were using it till there was the Netezza server system 6 version, and I think after 6 people have moved on to use more of the materialized views. Let's go on to the bad performance slide. I think we've almost covered all the reasons that you may have for bad performance except for limits on concurrency. Netezza does have a limit on concurrency, and that is at around 70 concurrent queries. After which point, Netezza will start putting you on a batch schedule and will not execute your query. So there are some limitations on concurrency in Netezza. And if you have an application which has a lot of micro queries that are being run on Netezza with a lot of concurrency, then you will see an inherent problem with the Netezza hardware itself, which cannot support concurrency beyond a certain level. So all the other things are manageable in the way you distribute your data, in the way you write your queries, but what is not manageable is limits on concurrency. And so that's one thing that I do want to highlight for everybody, right? Groom and generate statistics. Although Netezza system automatically maintains and generates statistics, you may want to generate statistics and groom command periodically. And the reason to generate statistics is in the zone maps, Netezza will always maintain zone maps for integer, date, and timestamp columns. But generate statistics will also help Netezza store other information about every column in every table, like the duplicate columns, the frequency of duplicate values in a column, right? Minimum values, maximum values, null values, unique values. All of these things for every column in a table is stored in the statistics in Netezza. When you run generate statistics, it's stored in Netezza host. So Netezza host is always aware of how each SPU stores each table in Netezza, right? So generate statistics command, right? So generate statistics command should especially be used when a table structure is altered or renamed, because then the Netezza host can be informed on what has been altered. It forces the Netezza system to update zone maps and thereby improve query performance. So if you want to update your zone map and improve your query performance, generate statistics can be very helpful. There are differences between issuing the generate statistics command and generating express statistics command on a table. Generating express statistics command is relatively fast and does as good a job as possible. But I do recommend that you issue the generate statistics command on every table every week. On a nightly batch, if you use generate express statistics, you should be fine because it's based on how column uniqueness is calculated. And really, that's not really going to impact your query in the long run a lot. Now, in order to understand why we need to use grooming, which is another way of defragmenting data in Netezza, and and releasing unused storage space in Netezza, you have to understand what Netezza does when you do an update or a delete on a column. When you do an update or a modification of a record in a table, when you delete a record in a table, Netezza does not actually physically delete that record from the hard disk. It basically maintains a version of that record in the hard disk. This is kind of counterintuitive for most people to understand that why does Netezza store that? There are lots of benefits of that multi-version concurrency. Right? There are lots of benefits of multi-versioning versioning the record in Netezza. And those benefits are useful when your system crashes. Right? They're extremely helpful in determining what went corrupt in your table. But it also, therefore, uses a lot of space in your tables. It also uses a lot of space in your hard disk. So periodically you want to release that hard disk. Periodically you want to release that all the versions of a record that you have stored in your table. And in order to do that, in order to release the multiple versions of a record, you need to use the groom command. Now you can use the groom command in multiple ways, and it's all described in this slide, but I'm not going to cover it in detail on what each of this does. I think the slide will give you an ample description of how you can change the how you can release different kinds of space storage. So I'm going to just quickly move on to materialized views. That is a different way of virtualizing your zone maps, so that we can then move on to Hadoop. So materialized views are used typically as a substitute for cluster-based tables. Right? You don't want to use cluster-based tables because there are different ways of querying data, right? And you don't need to necessarily physicalize, or essentially you don't need to actually implement a zone map through a cluster-based table, right? You don't want to organize your columns in nearby extents physically. You can also do it virtually. You can also virtually tell Netezza that this is how the data should be located on. And Netezza will behave as if it knows this virtual zone map and query it. Materialized views are not used as table surrogates. You cannot use where clauses on materialized views. And in order to use materialized views, you must select some kind of an organizing column, some kind of an organization key, right? And the typical process would involve rebuilding of materialized view with a new name, waiting for the completion of the build of the materialized view, and then dropping the original materialized view and renaming the view that you just created, right? A materialized view has the same distribution key as the original table, and it's typically created to create a thinner version of the original table. And it's created for virtualizing the zone map, right? You don't necessarily have to create a cluster-based table with admission date key. You can just create a table, a materialized view, which basically mimics that. And you can query that through your BI tool when you are doing admission date-based queries, right? And if you are using discharge date-based queries, you can create another materialized view which has the materialized view created on discharge date, if that makes sense. There are some do's and don'ts, and there are some revelations when you think about materialized views in Netezza. Right? You want to specify the order by clause. I already mentioned that you can specify only one base table in the from clause. Netezza materialized view does not allow multiple tables in materialized views. So this is the key that most people do not find very surprising in Netezza materialized view. But that's because Netezza materialized view is not for the purposes that you use it in Oracle. It's not a table surrogate. It is for virtualizing zone maps. That's the key to remember. And I'll skip forward. I'm going to skip the sequences part so that we can go to Hadoop, and we'll take the sequences part later into the next session. And I think we've sort of harped on the partitioning is not equal to distribution again and again. So we'll also probably cover that next time in the third session if need be. But it's pretty much described here why partitioning is not distribution. And I've already discussed why indexing is not zone maps. But you can get more details out of this slide deck on it. Where's the metadata of Netezza? All these tables are listed here, which will give you the metadata of Netezza. These are the tables where you can query the metadata. There is an NZ SQL functionality that you can use on Linux. I think I mentioned that last time, but I want to mention that again. And those NZ SQL commands are very simple. I love these NZ SQL commands. Everybody here, and I'm sure those of you who have implemented Netezza love your NZ SQL because it simplifies these commands a lot. You don't have to write the big long select statement. You can simply use the NZ SQL to get whatever you want. out of it. Workload management is something that Netezza also does very efficiently. It basically allows you to manage your concurrency of queries based on user groups and roles, based on your departments, based on your customers, so you can define all this resource allocation parameters in Netezza based on your different user groups, right? We also use it for different tenants or different customers in Premier Connect Enterprise. This will make sure that each department or user group or customer gets the same amount of resources on a Netezza box, and nobody's monopolizing on the resources. And Netezza allows you to do this with simple workload limits that you can specify: max number of queries that can run concurrently for a particular user group, max number of jobs that can run, the row limit. Nobody actually uses row limits because that's too terrifying. But you can also set row limits that any single query can actually query in Netezza. You can have query time limits, which is very useful. If some query is running more than half an hour, it should definitely be terminated, at least from a retrieval standpoint. So things like that. Netezza also inherently has a short query bias, that is a faster lane in its scheduling. Although short queries don't necessarily perform very well, Netezza with Netezza 7 has implemented the short query bias, which will at least give it a first in, first out kind of express lane where any short query will be performed in Netezza before any bulk or big data volume query will be performed. So again, this is just another way of seeing how you can set up job limits by customer or user group, or you can set up job limits based on, low priorities, higher priorities, critical priority. Another way of workload limits, I'm just going to skip this, and we'll probably talk this a little more when we do managing users and groups. Now we want to talk in the last 10 minutes very quickly about big data and Hadoop, right? I mean, Hadoop is claiming to solve problems that Netezza has claimed to solve problems, but at an even larger scale, right? The scales, when you look at this big data volume infographic provided by Wipro Technologies, it's pretty immense. What is going on the internet and how the data is multiplying, all your semi-structured and unstructured data. And the potential for it in healthcare is also pretty phenomenal. If you look at the upper right-hand corner, you're looking at your healthcare space, and you're looking at the potentials of saving and the potential growth of data, which is just phenomenal in volume. And all of this data, Netezza deals in terabyte data scale, right? It claims to go even to petascale data, but there are limitations. I think terabyte scale is probably more suitable to Netezza and its performance management. When you have all this, weird data types like videos and all this weird images and semi-structured data, complete text files, Netezza can have its own limitations when compared to Hadoop, which has no limitations in storing this data, in retrieving this data, in relaying this data back. So Hadoop comes as a system developed around the same time Netezza was coming into vogue, at the same time data warehouse appliances were coming into vogue, right? And it faced around the same problems. Modern data systems have to process far more data than has been possible, right? Facebook is estimated to be bigger than 100 petabytes of data. eBay and Twitter are estimated at 10 petabytes. Organizations like your organization itself is generating gigabytes of data every single day. So traditional systems, we've already looked at the bottlenecks of traditional systems. Faster CPUs and bigger RAMs, et cetera, et cetera. We saw that shared everything architecture, not distributed architecture. So you have all these problems in the old framework. Big volumes of data is the real bottleneck, right? So in order to solve this problem, we have a requirement for a new approach. One approach was to create a data warehouse appliance like Netezza, Greenplum, Vertica, right? That is one approach. The other approach to support failure, scalability, is to go the big data route, which is based on the concepts of grid computing and distributed computing, right? And Hadoop is specifically based on this, and it came out of the work done by Google in the late 1990s and early 2000s. Specifically, papers describing the Google file system and MapReduce. Hadoop is an open source project that is overseen by Apache Software Foundation, and it's written entirely in Java, right? So this is something very exciting for developers. They love Apache for their web servers, for the Tomcat for their application servers, and now you have an entire data environment which is now being managed by the Apache Software Foundation, which is open source and which is the anti-Apple model. It is completely anti-Apple. It's not integrated. It is software dominates and hardware can be anything, right? That is not to say that you don't have Hadoop administrators. Of course, there are going to be Hadoop administrators, but again, the emphasis here is on software developers. It's based on the same principle as data warehouse appliances, though. Distribution of data as it is initially stored in the system. We talk about data distribution constantly. Think about data distribution in the same manner when it comes to Hadoop. Data distribution happens exactly in the same way in Hadoop. Processing happens when the data is stored locally on the local node. Individual nodes can work on the data local to those nodes. Nodes should not talk as much with each other, right? Shared nothing architecture of Netezza. We do not share anything. Everything is happening locally. Data is replicated multiple times, at least 3 times in Hadoop, and you can go more. Is replicated 3 times. Data redundancy is important to support failure, right? Netezza replicates it twice. In Hadoop, it's replicated thrice, because data redundancy is everything in Hadoop. Reliability and infinite scalability. Netezza can scale as big as the box, but it can't scale beyond that box. Then you have to add another box, and that's a big hassle. Hadoop, there is no such hassle. You can keep on adding whatever you want to add, how many ever nodes you want to add, and they are all hot swappable, hot pluggable. There is nothing, no restriction at all, and this is a place where Hadoop really exceeds Netezza by far. The core concepts to remember in Hadoop are 2. Hadoop file system, this is the way it stores data, and MapReduce, the way it processes and retrieves data, right? The different sets of machine running HDFS and MapReduce are known as clusters, which is, your grid, basically a grid of computers. Individual machines are known as nodes in Hadoop. Hadoop ecosystem also includes many other projects, and we're not going to go deep dive into all of these other projects. Hive is typically used for your SQL style retrieval of your data. And then there are other Pig, HBase, Flume, Uzi. There are about 30 projects that are being managed by the Apache Software Foundation in Hadoop right now. HDFS, the Hadoop Distributed File System, is responsible for storing data on the cluster. MapReduce is the system used to process data on the Hadoop cluster. And the master program allocates work to the nodes. So you have a master SMP node just like you had in Netezza. And then you have hundreds of nodes like the spoos just working away in parallel to process and retrieve that data, right? I'm not going into the details of all of it because I need to hurry up. I have 2 or 3 minutes. Data locality, Hadoop will perform the map task on data stored locally on the node through HDFS, right? If this is not possible, map task will have to transfer data across the network as it processes data, right? So you talk about cross-node conversations. That can happen if the data cannot be processed locally on a node. So distribution is again as important as it was in Netezza. The reduced tasks cannot begin until all map tasks have been completed. The data can be relayed from the reduced tasks or from the map tasks to the reduced tasks, but they cannot be performed until all map tasks have been completed. When the map tasks are accomplished, data is transferred across the network to the reducers. Obviously, that makes sense. Fault tolerance, again, because of redundancy of storage, each node in Hadoop is hot swappable. and everything restarts automatically. A task does not require to communicate with other nodes working on the same portion of the data. If a failed node restarts, it is automatically added back to the system. So that's very important to know. If a node appears to be running slowly, the master node, which is what we call the SMP node, if you will, can redundantly execute another instance of the same task. This is also known as speculative execution, and it's the beauty of Hadoop that it does that. I mean, I don't know of any other system in the data warehouse appliance world which does something like that, speculative execution. If something is slow, it will just go ahead and allow another mapper to perform the same task, another node to perform the same tasks. Hadoop daemons, there are background tasks that run into Hadoop that a database developer or a Hadoop developer would not even know, but they are always running. Name node is your master node. It holds metadata for HDFS. Secondary name node, this is not a failover SMP node or a hot buy node. So there is no failover of the name node in Hadoop. This is an important problem that a lot of Hadoop vendors are trying to solve. This secondary name node is not a failover node. That's the key to remember. It performs some housekeeping items, but it's not a fault. It's not a failover node. Data node stores data blocks. Those are like your normal nodes. Job tracker is really a software service that basically manages and distributes MapReduce jobs. Task tracker, again, a software service, basically manages and monitors individual MapReduce tasks because each job is broken into tasks. And each daemon runs in its own Java virtual machine. So in other words, there is a master node has the job tracker, the name node, and the secondary node. All of these services are running on the master node. And as I said, the secondary name node is maybe on a secondary master node, but that is not a fault-tolerant SMP node. Slave nodes are basically your task tracker and data node. They perform the task tracking jobs, tasks, and your data node tasks. And now we have the comparison sheet finally that we wanted to look at between Netezza and Hadoop. Clients talk directly to data node once they know which data nodes store the data in Hadoop. This does not happen to Netezza. You have to talk to SMP node, right? I think we are running out of time and I'm being told that we cannot really go forward. So I'm going to leave this for your reference, this comparison sheet. The only thing I will mention, almost everything is identical. Hadoop is more scalable in scaling out and scaling up. Netezza is not scalable in scaling out. It is scalable in scaling up as much as possible. So scalability, there are some restrictions. Skill requirements, I feel particularly Netezza requires lesser skills than Hadoop. Hadoop will require higher skills right now because the market doesn't have as many Hadoop developers, but Netezza does not because it's actually, dumbness proof. We say a lot of bad developers succeed in Netezza because Netezza simplifies so many things. It actually is a bad thing, but Netezza does not require that amount of high skills. If you know SQL, you can work in Netezza without any problems. That does not mean that you should not learn Netezza's architectural concepts. They're important. And the biggest thing that Hadoop does not have and Netezza has is high availability of your master node, of your SMP node. Hadoop does not have that. Netezza has that right now. Greenplum has that. Hadoop also does not have co-located data processing, and this is something I would have liked to talk a lot more, but co-located data processing does not happen in Hadoop. This is the key to remember. I want to leave you with that thought that co-located data processing is still a work in progress. You can Google this on Google, of course. Google this on Google, and it'll tell you why co-located processing is still a work in progress. I would love to share more on that, but I'll try to take it up next time and discuss it more next time. So we'll leave it at that.
So thank you all for attending the session. As advertised in our newsletter that went out yesterday, we'll be hosting part 3 of this series on September 3rd. We're going to focus that session on managing users and groups, Netezza performance optimization, and discuss some examples of query and table optimization specifically for healthcare data. Please bring any specific challenges or questions to this session, as we'll dedicate a little more time to Q&A. The presentation that we've just reviewed with Part 1 and Part 2 is available already in our Data Alliance community on Premier Connect. This recording of Part 2 will be available in the next couple of days. If you have any questions about the material, please feel free to email us the address from the invite. And if you could please take just a brief moment to close to fill out the survey prompt and let us know also any ideas or things you would like more detail on in the comment box, that would be great. Thank you so much for your time and staying over for a couple of minutes, and have a great day.